Welcome, everyone. Today, we're diving into the world of cloud computing and virtualization, and we're going to build our own small cloud environment from scratch. Whether you're new to the topic or looking to deepen your understanding, this session will give you a hands on look at how the cloud actually works behind the scenes. So, let's start with the basic. So, understanding the cloud computing. Cloud computing is all about delivering IT services over the internet on demand. Think servers, storage, databases, networking, even analytics. You access what you need when you need it without owning the physical hardware. One of the key principles of cloud computing is on demand services. Just like you turn on for a tap of water, you can turn on computing resources as needed. This model reduces upfront costs and allows businesses to be more agile. Another core idea is resource pooling. Instead of dedicating a single server to one task, cloud providers pool resources and allocate them dynamically. This is like a utility bill. You only pay for what you use, and resources are shared efficiently across users. So for the scalability and flexibility, so these are huge advantages of the cloud. You can scale up during peak times and scale down when demand drops, all without buying new hardware. This makes it perfect for startups and growing businesses. Next slide is the power of virtualization. So how does this work under the hood? The virtualization, this technology creates virtual versions of physical hardware, allowing multiple virtual machines or containers to run on one physical system. It's what makes the cloud so efficient. So the virtual machines are complete operating systems running on a hypervisor, isolating applications and offering high compatibility, while the containers are lightweight, portable packages that include everything needed to run an application, sharing the host OS kernel. So, deploying a virtual OS with VirtualBox. So, the first step is to install VirtualBox. So, you need to download and install Oracle VM VirtualBox on your host operating system. This free open source hypervisor enables you to create and run virtual machines. For the next step, we have the create new VM. So walk through the VirtualBox wizard to create a new virtual machine, selecting the operating system type and allocating resources like RAM and virtual hard disk space. So for the last one is to install the guest OS. So mount an ISO image of your chosen guest OS, for example Ubuntu, CentOS, and proceed with a standard installation process within the newly created virtual machine. So next is resource allocation management. So effective resource allocation is crucial for optimal performance in a virtualized environment. So this is how to will demonstrate how to adjust the CPU cores, memory, and storage for your virtual machines. So for the dynamic adjustment, it modifies resource limits on the fly to meet application demands without downtime. Monitoring tools, they utilize built-in VirtualBox tools to monitor resource usage and identify potential bottlenecks. And for the optimization, so you need to learn best practices for allocating just enough resources to avoid waste while ensuring smooth operation. So for the VMs versus containers, so the difference is VMs offer full OS isolation, making them ideal for running different operating systems or applications with conflicting dependencies. So each VM includes its own kernel and OS overhead. So for the containers, they share the host OS kernel, making them incredibly lightweight and fast to start. So it is perfect for microservices and rapid deployment, minimizing the resource consumption. So the containers are lighter and faster. So it depends on what uses you need when choosing between the two.
I will demonstrate a cloud-like environment using a virtual machine and Docker containers. This will show virtualization, resource allocation, and the difference between a virtual machine and a container. Step 1. Show the virtual machine, VirtualBox. This is my Ubuntu virtual machine running in VirtualBox. It has its own operating system and allocated resources like CPU and RAM. Step 2. Check system resources inside the VM. Command htop. If not installed, sudo apt install htop-y. This command shows CPU and memory usage inside the virtual machine. It proves that the VM has fixed resources assigned by the hypervisor. Explain. IaaS. This virtual machine represents Tidry Infrastructure as a Service. IaaS. I control the operating system and installed software, just like in real cloud platforms. Reading Twin. Step 3. Check Docker installation. Command. Bash Docker version. This command verifies that Docker is installed on the system. Step 4. Run a web server using Docker container. Command. Bash Docker run dp8080:80. Name web demo nginx. This command starts an nginx web server inside a Docker container. It runs in the background and maps port 8080 on my system to port 80 inside the container. Since it already input, next. Step 5. Verify running container. Command. Bash Docker ps. This command lists all running containers. We can see that the web server container is active. Step 6. Access the web service. I will now open the web service in the browser. URL. http:// localhost 8080. This page proves that the containerized web service is running successfully. Step 7. Demonstrate container resource limits. Command. Bash Docker run D9 name limited nginx var memory 256 megabytes. Yarn capacity quad 0.5. Yarn P8081:80 nginx. This container is limited to 256 megabytes of memory and half a CPU core. This shows how containers efficiently control resource usage.